computer. Right. So this is chapter 3, just to recap. Just to recap what we have discussed. Okay. So it's about producing precipitate. Okay. Where from the precipitate, you can do some analysis. Okay. Because we are talking about analytical chemistry. Yeah. So we do measurements based on analysis of the precipitate. Before this, you do analysis based on titration. You measure the volumes, but this one you measure the mass. So of course, you have to be well versed in terms of all these. Okay, the terms, digestion, absorption, what is the meaning of precipitate, precipitation process. Re-precipitation is you just repeat the precipitation. Yeah, you just want, because we need to, sometimes we need to purify. We wash and we re-precipitate because we want to make sure we have a pure precipitate. Yeah. And then the terms like counter ion, motherly core, and supersaturation. Yeah. And of course, when you start the process of precipitation, okay, there are sometimes you might get colloid. I think I have presented before that colloid is a small size precipitate, and you might get crystalline, yeah, the big size precipitates. And there are terms like co-precipitation, okay, which you might encounter, okay, co-precipitation. And usually we don't want this because this will contribute to contamination of the precipitates. That's why we do not want this to happen. But of course, we have to discuss this. Yeah? Co-precipitation, how it happened, the resources, okay? And the term also, baptization. So what is baptization means? Yeah? Okay, coagulation is the what we call as when the colloid is formed. Okay, they will form larger particles by coagulation process. They clump together. Okay, right. Describe structural properties of chelating agent. Okay, this one is precipitating agent. Okay, so I will recap back what is precipitating agent. And then, all right, identify the type of source of charge. This one also we will discuss what types of charges, okay, whether it's positive charge, from what kind of ions that will form on the precipitate. And of course, the last part is the calculation part. I believe that, I don't know whether you have completed your lab report, because tomorrow we don't have lab. Tomorrow is public holiday. So I don't insist on you submitting your lab report. So you still have time, yeah, to do your lab report until next week. Okay, so this is the whole process. Okay, analyte means that the one that you wish to analyze. So last lab we want to analyze chloride, right? And then we put precipitating agent. So remember that we want to analyze chlorides, and then we put, I think it's case nitrate. Okay, and then you have precipitate of AgCl, the white colored precipitates. So from the mass of the precipitate and from the stoichiometric reaction, you can calculate the amount of chloride. Okay, so this is how it works. Okay, and this is what you have done during the experiment. You have to prepare the solution, do some mixing, and then you let the reaction to happen. You end up with the white precipitates. Yeah, and then of course it requires time to react, because remember that you have colloid and you want it to be into larger particles, which is called crystalline, okay, crystal particles. So this will take time, okay. So the first process, when you mix the reagents together, okay, please mute first, okay, when you enter. Right, so this is the first process. When you mix all the reagents, okay, you will have nucleation, okay. So of course you start with colloid, small size particles, and then when you give time to the reaction to digest, then they will start to form larger particle, okay, and they will hopefully form crystal instead of just colloid. Yeah. So this is what you have done. Okay, that is what digestion is all about. And then when probably based on your practice, you know when the reaction stop. Okay, how do you know? Is when you have no more precipitate. Yeah, when you have no more precipitate, a new precipitate form, that means that all the chloride has been precipitated into AgCl. Okay, so when you have that condition, then you can do filtration. Okay, so last experiment, you have used the vacuum filtration system, and then you did a bit of washing by using acid. Yeah, so there is a reason why we need to use acid, acidified water, electrolyte, okay, to wash the precipitates. Okay, all right, and drying requires time. Okay, if you don't do enough drying, then you will have inaccurate data. Okay, because in the end, it's the mass that you will obtain, and then you will have to do calculation based on the mass. So these are all gravimetric all about. Yeah? Of course, when you do gravimetric analysis, you don't want the precipitate to be soluble. Yeah, you want the precipitate to have low solubility. You don't want it to be easily dissolved. Okay, because we want the precipitate to be stable. Even though we wash, it will not dissolve in the washing solution. And we want the precipitate to be easy to filter. So that's why we do not want colloid. We want the precipitate in the form of crystalline, which is larger particles compared to colloid. And because we want it to be easy to be filtered. And of course, we do not want the precipitate to be reactive towards air, water, or surrounding, yeah? Because this will contribute to the contamination, and this will give us inaccurate reading. So this is the one that we must be cautious about when we do gravimetric analysis. And this one I have talked about the sizes. Okay, this is our target. We want the precipitate to have the size, the crystalline precipitate, and because of course they have larger size, easy to filtrate, and there is a possibility of higher purity compared to colloid. Yeah? And I also talk about this last lecture. How do you control? Because your target is to have crystalline precipitate. So you want to make sure RSS is small. Okay. So in order to control the RSS, okay, we have to control the Q and S. So concentration of the solutes means that the precipitating agent as well as the reagent. Okay, means that the argentum nitrate or the analyte that contain the chlorides, those has to be in low concentration when you start to do the analysis. Okay, equilibrium solubility. So I think all of you has come across this KSP solubility product. So in order to have a low S, okay, we can do this. Sorry, higher S. Sorry, yeah, we need to have a low Q and higher S. Okay, so this is what we can do to have a small RSS using dilute solution. So everything must be diluted, low concentration, and then you add slowly. Remember that you use burette, okay, to do the titration. You don't do titration, actually you keep adding the precipitating agent in low amount by using burette, and you do stirring so that the reaction is, okay, let me mute, right? So that the reaction is homogeneous, yeah? Homogeneous, and you do warming up the solution. So this will increase the S, equilibrium solubility, because if you increase the S, you can see that RSS is proportional, inversely proportional to S, so RSS will go down, yeah? All right, if you have any question, you can just stop me, all right? You can stop me and ask questions. So that's when you can unmute yourself. Okay, so this is the process, how the precipitation process happen. Of course, it starts with nucleation process, okay, where you have colloids, right? And then what happened here? All right. And then you have, next one is the particle growth, where the colloid combine through coagulation process. Okay, this is coagulation process, coagulates process, and forming what we call as crystalline precipitates. And this is the one that we want to have, right? Now, what happened here is you do not want nucleation process to dominate. Okay, we want particle growth to dominate the process. Okay, because there are two processes going on, nucleation as well as particle growth. So nucleation might dominate the process, the whole process, it might dominate, but we do not want this to happen. Yeah, we want particle growth. We want particle growth to dominate the process. So again, we are using RSS, okay, to make sure that particle growth is the main process that happens. So we have to increase S, which is the solubility, and decrease Q. Q we know by using these steps. Of course, you start with a very dilute solution, and then when you add the reagent, you add slowly, and then by stirring, because you're gonna have a homogeneous solution. How to increase S? Okay, you can warm up the solution. So remember that during the experiment, you did warm up the solution. It's not boil, but you warm up the solution so that you have increased S. Okay, and then probably you add a bit of acid to make sure that everything is soluble. So you can have here, if RSS is large, nucleation is favored, which we do not want, and colloidal suspension tend to be formed, right? If RSS is small, particle growth will be the dominant, okay, process, and that's what we want. And what we get is resulting crystalline precipitates, which is what we target for. Okay. Colloidal and crystalline precipitate have their own problems, but colloidal are worse. Okay, so that's why we need to counter the issue. Okay, how are we going to minimize the formation of colloids? Okay, so let's talk about this example. Okay, so you must know when the reaction happens. You must know what is the analytes and what is the precipitating agent. So in this case, we want to detect chloride. So this is the analyte, and this is what we call as precipitating agent. Okay, usually I write it PPT, precipitating agent. Okay, so whenever we do gravimetric, these two okay, reagents are very important, precipitating agent. Yeah, and this is what we call as precipitate. Okay, right? So precipitating agent, precipitates, analytes, those are the things that you have to familiarize yourself, okay? So now, in the end, you get AgCl as the precipitates, okay? So this is the nucleus that forms at the beginning, okay? But you can see, of course, in the beaker, okay, in the beaker, originally you have so many other ions like nitrate, okay? And also you have excess of argentum plus because it comes from here. You might also have sodium plus because it comes from here, okay? So there is a possibility of contamination. Yeah, you can see this is the precipitate that we want, which is AgCl in the middle, but unfortunately it will be covered by other ions. You have Ag plus, you have nitrates, okay? So we need to remove all these. That's why you need to have washing process, okay? So when we have washing process, you need to make sure that the washing only will remove the outer part. It will not destroy the AgCl precipitate. So that's why the washing solution has to be suitable. Okay, so the outer layer of the precipitates, okay, let me clean up this one. So the outer layer means that the Ag plus here, it is called primary absorbed layer. Okay, the outer layer of the precipitate contains both Ag plus and Cl, which tend to attract additional Ag plus to the surface. So this one is called the Ag plus primary absorbed layer. Okay. Okay, there are two processes, okay, that you need to understand. Okay, please, I will try to explain to you. There are two different stages. Okay, let me, okay, I don't have any, okay, let me, okay. I can add the slide. Okay, one is, okay, if you look at here, stages one, if the precipitating process, okay, precipitation process is at early stage, means that you start to add the precipitating agent. Okay, so precipitation process is at early stage. You start to add the precipitating agent. Okay, so you have to think about the one that is in excess. The excess means is much more than the other one. So since that it is early stage, of course, the precipitating agent is less because you just start adding it. Okay, but this one is in excess, means that it is extra, right? Okay, any questions? This is at early stage. The precipitation is still in process. So the analyte is in excess, but the precipitating agent is being used, so it's finished. So if you have AgCl, okay, as the nucleus of the precipitate, now if you look at here, the one that is in excess now is chloride, okay, and sodium plus, right? Okay, any objection on that? Okay, so we need to determine which one is the primary absorbed layer. So the one that is primary absorbed layer is chloride. Because chloride is the one that's involved in the formation of the precipitate. Sodium is not involved in the precipitate process. Okay, so now at the beginning of the precipitation process, chloride will be the primary absorbed layer. Okay, and of course the charge is negative because chloride is negative. So this is primary, and then you're going to have the secondary. Secondary will be sodium plus. Okay, any questions? Okay, this is at the beginning. Okay, now if you have, I have to use this empty space. So the second process is when the precipitation is over. Means that all chloride has been precipitated. So if you look at here, okay, what happened is Ag nitrates, because you keep adding it, will be in excess. In excess. Okay. The sodium chloride supposed to be finished. Okay. So now if you have the AgCl nucleus, okay, so the primary layer should come from Ag plus. Just like this picture. So the primary layer now is Ag plus. And the secondary layer comes from the nitrates, which is the second layer. Okay, so this is the process of how you have secondary layer, primary layer, and the secondary layer. Okay. Okay, so this is what it talks about. So there are two stages at the beginning, which is this one. Okay, and after the precipitation process ends, where we will run out of chloride and sodium as well. Okay, questions? This is a common exam questions. You have to explain about the primary layer, the secondary layer, at the beginning of the precipitation process as well as the after we achieve the precipitation process. Okay, I assume no questions. Right, so this one we are done, how to get good precipitates. Okay, so coagulation process I have described just now. That is the process of the nucleus or the colloids, okay, clump together where they form crystal, larger particles. Okay, that is coagulation. And opposites of coagulation is peptization. So when the coagulated colloid, okay, the colloid, the small particles coagulate, clump together, it can also revert, means that it can also broken down after it is forming crystal. It might broken down into colloid, and it is called peptization. So this peptization can happen if we use a wrong washing solution. So that's why washing solution must be correct. The formula or the suitability of the washing solution must be suitable for the one that you want to wash the outside layer. If it is not suitable, then you might end up with peptization. It will break down into colloid. Yeah. This one I think I have discussed. This is the heating, the warming up of the solution also can help remove all these contaminants. Yeah. Right, increasing the electrolyte concentration of the solution. Okay, this is the washing solution. Yeah. So that's why in the washing solution, you add a bit of acid, okay, because we want to increase the electrolyte concentration in the water. So when you have a bit of charges in the washing solution, it might attract all these contaminants from the surface of the precipitate. Okay, so this is the issue of peptization. So we have to be careful about the washing formula. So these are other examples of how you treat colloidal precipitate. You want to change it into larger particles, which is crystalline. I think it's the same content. Yeah. So crystalline precipitates, this is what you want because it's easily can be easily filtered, and you will have less contaminants because the smaller the particles, the surface area is greater. But the larger the particles, the surface area is lower, and you're gonna have less contaminations. Yeah. Okay, next one is co-precipitation. So what is co-precipitation? Okay, so precipitation, the one that you do in experiment, the one that you mix together and you wish to get AgCl, right? Using the example. Okay, so those are the one what we call as precipitation, main precipitation. I just put PPT, precipitation. Yeah. This is the one that we wish to get. But unfortunately, during the process, there might be other precipitates apart from the main precipitate that we get. So that is what we call as co-precipitation. Okay, because when you mix together in the beaker, you don't know. You might get the one that you wish to get, which is AgCl, but at the same time, you might also get other precipitates. Yeah? So these are the resources of co-precipitation. and this will contribute to the contamination. Yeah, and when you have contamination, other precipitates, you will get inaccurate data in the end, right? So this number one source of co-precipitation is surface absorption. This is quite simple because the one that we discussed just now, primary layer, secondary layer, is surface absorption because of the charges. Okay, because of the charges, we're gonna have surface absorption, and this will contribute to the impurities. Yeah. So this is how we counter. Okay, the same what we have discussed, washing. You can do re-precipitate, means that you dissolve back and then you precipitate once again to get a pure precipitate. Yeah, this is what we call re-precipitation. Okay, number two, the sources of co-precipitation is what we call as mixed crystal formation. Why? Because some ions, they have similar, not to say similar, but almost similar size. Okay, some ions have the same charge and have sizes almost similar. For example, here, if there is a presence of plumbum or strontium, then you're going to have a mixed crystal containing plumbum sulfate or strontium sulfate. Okay, in fact, you want to, in this case, you want to analyze or you want to measure the content of sulfate, and then you use barium sulfate, and you want to have barium sulfate as the precipitate, but unfortunately, if the sample, because you cannot control, sometimes the sample contain other metals as well, and you end up having this precipitate. Okay, not just barium sulfate, but you're gonna have other precipitates. And when you weigh the precipitates, you're gonna have different inaccurate data. So this is what we call as mixed crystal formation. So when you have this kind of situation, there's nothing that you can do. You cannot just wash, you cannot re-precipitate. But what you can do is, before you do the reaction, before you do the precipitation process, you have to remove the plumbum and the strontium first. Okay, that's the only thing that you can do. Okay, just now is number two. Number three is occlusion and entrapment. Okay, so if the crystal growth is too rapid, right, some counter ions don't have time to escape from the space. Okay, we do not want these counter ions to be trapped, yeah, in the crystal structure. Okay, I hope that you understand when I say crystal structure, because ions, okay, cations and ions, they will form crystal. Okay, so we do not want any other ions to be trapped in the crystal structure. Okay, and there is also a possibility of solvent trapped in the crystal structure as well. Okay, so this is what we call as occlusion and entrapment. Okay, right, so that's why you have to do things slowly, take some time, stirring, because those stirring will help to remove the contaminating ions. And if the process of precipitation is too fast, is too rapid, then we might have a trapped contaminants, a trapped foreign ions in the crystal. So this will contribute to the inaccurate data when you weigh the precipitate. Okay. So the steps for solving these issues: digestion, same steps to reduce RSS. You have to use dilute solution, warm solution, and stirring. Okay. Okay. This one. Of course, you have to dry. And these are some applications. Okay. Some applications. So applications means that you have to know which one is the precipitating agent, which one is the analyte that you wish to analyze in this case. Okay, why is it? Okay. Right, so the last part will be calculation. So I'm not going to discuss calculation today because we need to discuss it by using, just a moment. We need to discuss it by using whiteboard and all that. So using tutorial questions. So I suggest if you have time after this, look at the tutorial questions. But this is the only formula that is important in gravimetric calculation. Okay. So if you want to use this example, this calculation to do your lab report. So this is the one that you need to use. Gravimetric factor. So I think we still have time, okay, because you only need to submit by next week. So we can discuss this calculation during our lecture next week. So you can see these are the examples, okay, of calculation questions related to precipitation, related to gravimetrics. You just have to be well versed in terms of gravimetric factor. And this is the only formula. So it's not that difficult. Okay, any questions before we end? Because it's not going to be long. I'm not going to discuss any other technique today. Okay, solubility product. I think you have discussed this during your last subject. I think your last semester subject, KSP. So I don't think we need to repeat that again. Okay.